Excuse me. All right, let us begin. This is volumes 2, which I am subtitling Washers Along the Horizontal. And this is the first example that we're going to be doing. So we are taking this area here, which is bound by x plus square root of x plus 1, which is the top curve, bound by y equals 1, which is the bottom line, and bound by x equals 4, which is this line here, and bound by x equals 0, which actually I think that's just a point. So really I'm not quite sure why we need to bound it by x equals 0. But we get this area here, and then we're going to rotate this area around the x-axis, and we can first way you can think about this is you get this shape here, and you could think about getting the area of the entire shape. So if you were to forget about the hole that goes right through the middle, but you could figure out the area of the entire shape, right? So you could find the volume, and the volume of that entire shape would be the integral from 0 to 4 of pi r squared, and in this case the r squared is the square root of x plus 1, and then you'd get take this integral and you get the area of everything, and then once you get the area of everything you would take out of the middle that cone. Well, that cone is pi times you have this, let's see if I can do this, you would end up with a cone that's along here, right? So you'd have that cone. Not the best picture I've ever drawn, but you'd have that cone. That cone would have a radius of 1. So when we're removing the area of that cone, then that would be pi r squared, pi times 1 squared, and then the length of it would be times 4. Right? So that would be one way to do it, was you find the entirety and then you would take out the cone that's in the middle. Right? Another way to do this, which turns out to be for a lot of problems, let's see if we can leave both of these up, there we go. If turns out for a lot of problems is going to be a more useful excuse me, way to do this, is to think about making a washer. And here I've drawn this washer, and what I want to do is I want to find the volume of this washer. Well, to find the volume of the washer, we're going to find first the area, the surface area that I have colored here in red, and then you're going to multiply it by the width, and the width is going to be dx. Right? So the washer itself, let me draw down here this washer. So the washer itself has got a outer radius here, which is this distance here, is the square root of x plus 1, and then the washer has got an inner radius that's right here, and the inner radius is 1. So then if we want to find the area of this disk here, then that's the way we're going to do that, is take the area of the outer circle, which is going to be pi r squared, and in this case the outer circle is the radius is the square root of x plus 1. So this right here is the area of the outer circle, and then we're going to subtract from that the area of the inner circle, which is pi times 1 squared. And then for each one of these, right, we're going to Right, so this is the area of the front face of our washer, and the width of our washer is dx, and then we're going to integrate from 0 to 4, and this is going to give us the volume. Right? So this whole thing is the volume of one of those disks, disk being dx wide, and then we're going to add up all of the disks from 0 to 4, and that's going to give us the volume of our figure. Right? So let me just do that here quickly for you, for us. Right? So then the volume ends up being the integral. I'm going to take the pi to the outside, integral from 0 to 4 of, I'm going to take the square root of x plus 1 and I'm going to square that out. That's going to give me front is x, outer and inner is going to be plus 2 root x plus 1, and then I'm going to take this and square it. So then we would have minus 1. This is dx. We can simplify that. Well, actually, instead of rewriting it, let's just notice that this is 1 plus negative 1. So this, that part disappears, right? So those two cancel out. So then we're taking the antiderivative of x and the antiderivative of 2 root x, which is going to give us, we'll carry the pi, and then the antiderivative is going to be 1/2 x squared plus, this is 4/3 x to the 3/2, and we're integrating all of this from 0 to 4, which then is equal to pi times, we plug the upper bound in, 4 squared divided by 2 plus 4/3 of 4 raised to the 3/2, which is going to give us 8 plus 32/3, and the final answer ends up being 18 2/3 pi. Right? And that is example 1, and I've pulled that off in 7 minutes and 50 seconds. Ta-da!